Assalamu alaikum and a very good morning to all. Today we are going to start with the same chapter, redox reaction, with a new unit that is 7.5, oxidizing agents and reducing agents. Oxidizing agents are basically the agents. These are, you can say, helpers which help in the oxidation process of the other atoms or ions. So we can define in this way: oxidizing agents is a substance which bring about oxidation. How oxidation happens? By removing the electrons from another atom. This oxidizing agent itself, it gets reduced, but the other atom that is oxidized, that is oxidized. So an oxidizing agent, in a common words, you can call a thief of electron. He basically snatched the electron from other atom or ion and itself get enriched with the excess of electron. An oxidizing agent increases the oxidation number of another atom or an ion, and when this happen, the oxidation number of the oxidizing agent that decreases. Now, to explain these two bullet points, let's take an example of a very famous reaction. This is a complete equation reaction, redox reaction, in which oxidation and reduction is happening side by side simultaneously. This is your ferrous chloride, this is your serous chloride, this is ferric chloride, and this is cerium chloride. In these example, you can see in this reaction we have basically iron here that is in a +2 state, that is in a +2 oxidation state. Chlorine, for one chlorine, that is -1. For two, it will be -2. Cerium over here, that is in a +4 state, that is in a +4, and for one chlorine -1, and for four -4. In this compound, this is called as ferric chloride. For one -1, and for 3 chlorine we have a -3. Iron, in this case, it is the oxidation state that is +3. That is what? That is +3. So we have two types of iron. One is in a +2, another is in a +3 state. So the one with a higher oxidation number, that ends with IC. The name ends with IC. So it is called as ferric. And the one with a lower oxidation state, that ends with, the name ends with OUS. So this is called ferrous. This is called what? Ferrous. So this is called ferrous chloride, and this is called ferric chloride. Now, in the another compound, we have cerium in +4, and in this case cerium is in the +3 state and chlorine is in the -3. So one again in the higher oxidation state, another in a lower oxidation state. So the one with the lower oxidation state, that is called as what? Serous, and the one with the higher, it's called it's called what? It's called cerium. So this is called cerium chloride, and this is serous chloride. So now we have to look where oxidation is happening and where reduction is happening. This is a type of reaction in which gain and loss of electron that happens simultaneously. So this is a reduction oxidation reaction, which we call it in a shorthand redox reaction. So any reaction where electrons are transferred between reactants, that is called as reduction oxidation reaction. These are reactions where one substance wants an electron so badly that it takes it away from another substance. You can see over here, iron here, that will give its electron to this cerium. So what will happen, cerium here, it will change from +4 to +3. This give you an idea there is what? Gain. There is what? Gain of what? There is a gain of 1 electron by cerium. So what happened? Cerium, it changes from +4 to +3. In the iron case, iron changed from +2 to +3. So what do you think what has happened? there is what? Loss of electron happen. How much? By one amount. One electron is lost by an iron, and that one electron was gained by the cerium. So this gives us an idea, okay, the cerium over here, this is acting here as an agent which help in the oxidation of the iron from +2 to +3, and itself get reduced. So this cerium by itself, it is now enriched by an electron, but it has lost, it has stolen the electron, snatched the electron from the iron, due to which loss of electron is now, you can see in the iron from +2 to +3. So over here what has happened, the spectator ion, like in some time in a reaction we have some ions which are spectator, they do not take part in the electrochemistry of the reaction, so we write that as a net ionic equation, which we have done over here in the blue. Now cerium +4 took an electron from iron +2. This is oxidation reduction reaction. In this example, iron +2 is oxidized, loss of electron happen, and cerium +4 is what? Reduced. So you can say cerium is oxidizing agent and iron +2 is a reducing agent. Oxidizing agent is an agent which help in the oxidation of other atom or ion, and itself get what? Reduced. It is enriched with electron. The charge of iron went from +2 to +3, that is, it lost an electron. Here what happened? Oxidation happens. Oxidation takes place. Now we can define what is oxidation. Oxidation is what? That is loss of an electron by a substance. Oxidation is a loss of an electron by a substance, which you can see in the iron. Iron changed from +2, iron changed from what? From +2 to +3. In chemistry, you know, okay, when the oxidation number increases, this gives you an idea, okay, from this iron, 3 electrons are lost, but from this iron, how many electrons are lost? 2 electrons are lost. Now we can move to the statement, an oxidizing agent, what it do? It increases what? Oxidation number of another atom. Oxidizing agent increases the oxidation number of another atom. So this was an oxidizing agent. This was what? This was oxidizing agent. And what it did? It increases the oxidation number of iron from +2 to +3. You can see there is an increase in the oxidation number by that oxidizing agent. Now oxidation number of the oxidizing agent, what? It decreases. Now we have to identify, okay, which ion is acting as an oxidizing agent. So I told you that is cerium. Because why? Because cerium changes from +4 to +3. It seems there is a gain of 1 electron. It means it has stolen 1 electron from iron. So oxidizing agent is an agent which help in oxidation of the other, but itself get reduced. Now it is enriched with electron, with extra electron from the iron. So you can see the oxidation number of oxidizing agent, what it happens? Decreases. So cerium from +4, it decreases to cerium +3. So these two statements, now I know, now it will be easy for you to understand. Now they have talked about the oxidizing agent. One is oxygen, second is chlorine, and potassium magnate. You can have this potassium magnate in the form of KMnO4. What is the oxidation state? That is what? 7. Now they have continued here. Cerium, the charge of cerium that went from +4 to +3, from +4 to +3. So it is gain an electron. What cerium has done? It's gain electron. From whom? From the iron. So this process is called what? Reduction. This process is called as reduction. So reduction is what? A gain of electron by a substance called as reduction. Now they have discussed about how this transfer of electron happens. Now iron +2 to +3, when it changes, there is a loss of electron. You have to write it over here on the right side of the half reaction. In a cerium, there is a gain where what happened? The oxidation number decreases, but in the oxidation process, here oxidation happens. So oxidation number increases by the loss, but in the gain of electron, oxidation number or state that decreases from +4 to +3. Now we need two half reaction to make a reaction. we add them together. This was an oxidation reaction where iron plus 2 changes to iron plus 3. Oxidation number increases in the oxidation process by the loss of electron, whereas when there was a reduction gain of electrons, so the cerium, it changes from plus 4 to plus 3. Okay, so one is acting as an oxidizing agent, another acting as a reducing agent. So in this example, cerium is acting as an oxidizing agent. It is an agent which is helping in the oxidation, in the loss of electron by another atom, and itself is reduced. Okay, so notice that electrons on both sides of the half reaction must cancel each other when you add them together. So the electrons over here, they will cancel because they are present on the opposite side. So you can see this is the half net ionic reaction. Okay, now we have to talk about a reducing agent. Reducing agent, the another name for reducing agent is a reductant. It is an agent, it is an helper which helps in the reduction process of another atom or an ion. How he is going to help this agent? By donating or by giving the electrons to another atom. And what will happen, that atom itself will get reduced, it will get deficient. So this reducing agent, you can call in a very common words, this is, it's very generous in giving the electron. It gives its own electron and itself get deficient. It enriches other atom or ion by providing the electron, but itself become very deficient because of loss of electron. So you can call he or she, or you can call, I always call them he or she, but keep this thing in mind, all of them are non-living. So this reducing agent, what it do, it's very generous in giving electron, in a very common words. A reducing agent decreases the oxidation number of another atom or ion, and when this reduction happens, the oxidation number of reducing agent, what happened? It increases. We can study the same reducing agent by the same example as well. In this example, you can see we have an iron and we have a cerium. So we will call this iron as a reducing agent. This will be what? This will be a reducing agent. Let me erase all of okay, this iron here, this is, we will call it as a reducing agent. Why this is called as a reducing agent? Because this is an agent, this is an helper which is helping in the reduction process of the other atom or ion. It enriches other species, but itself get very deficient. This is very good, this iron is very good in giving the electron. It is very generous in giving the electron to the cerium. So when it do so, when it gives electron to the cerium, so you can see the oxidation number of this iron that get increased from plus 2 to plus 3. We will move over here what they have written. K, a reducing agent decreases the oxidation number of the another atom. Okay, now oxidation number of reducing agent, what? It increases. Now we are going to study first this statement. Oxidation number of the reducing agent that increases. You can see from plus 2 to plus 3. Now this is fine. Now what was another statement? Reducing agent decreases the oxidation number of another atom. So this reducing agent will, what it will do? It will decrease the oxidation number or state of the cerium from plus 4 to plus 3. So there is a decrease, you can see here. Okay. Now we will move further. Now they have talked about other typical example, that is hydrogen potassium iodide. It's written as Ki. And we have some other example as well, reactive metals such as aluminum. They all are acting as a reducing agent, like they are good in giving the electron. They itself get deficient and it enriches the other electrons. So they are very generous in providing the electrons. Since oxidation reduction occur together in every redox reaction, there must be an oxidizing and reducing agent in every redox reaction. As I discussed with you, okay, we can study reducing agents from this example as well, because this is a reduction oxidation. It's a redox reaction because oxidation and reduction are happening simultaneously. Okay, now they have given us an example This is an ionic equation. The complete net reaction has been taken out. Like here, what they have done here, it was potassium. So K is what? +1. So when this is removed, this will become an ion. Okay, so K-4 over here, manganese oxide, this act as an oxidizing agent. So an agent which help in oxidation of the other atom and itself get what? Reduce. So you can see here oxygen here is in a -2. So for the 4, how much? -8. That will be what? 8. Okay, let me do it again. Erase this one. Okay, so the total charge on the oxygen, that is -8, +1 to neutralize manganese will be in the +7 state. Now over here you can see K manganese from +7 it has changed to +2. So manganese oxide is an oxidizing agent because the oxidation number of manganese that decreases from +7 to +2. So oxidizing agent is an agent which help in the oxidation of the other compound and itself get what? Reduced. So you can see, yes, manganese has gain electron. How much electron are gained? 5 electrons are gained. Manganese oxide has increased the oxidation state of iron from +2 to +3. But here you can see iron is in +2 and in the product side it is in iron +3. So this means loss of electron has happened in the iron because it has moved to +2 to +3. So that electron, 5 electron which are lost by each iron, 1 electron by each iron, total of 5 electron, they are taken away by single manganese. They are taken away by single manganese, and as a result the manganese changed from +7 to +2. And you can see here what we have, like 5 iron, each iron has lost its 1 electron and they are taken and eaten away by this manganese. So iron here is acting as a reducing agent. It's acting as what? Reducing agent. This is your R and A. This is reducing agent which help in the reduction of other and itself get what? Oxidized. And manganese or K-4 is acting as what? Oxidizing agent, like the agent which help in the oxidation of the other. It has lost the electron and itself get what? Reduce. So this you can call manganese over here is a thief of electron, and this iron is very generous in giving the electron. So iron +2 is what? It is oxidizing agent because oxidation number of iron increases from +2 to +3, whereas iron +2 has decreased the oxidation state of manganese. Here it was +7, here it was what? +7, and it changes to what? It changes to +2. If you want to calculate the oxidation state of a manganese from this ionic compound, so how you're going to say, okay, the total charge on this ion is that is equal to -1. I know the charge, the state on the oxidation on 1, that is -2. So on 4 it will be how much? It will be -4. 2s are 8, and this is for manganese. Okay, is equal to -1. I'm going to find for manganese, so I will leave manganese over here, and this -8 will shift to the other side with -1, so it will change into +8. So +8 -1, the sign will be of the cap of the higher number, and you will minus it, so it will be equal to 7. So you have calculated the oxidation state of a manganese in this ionic compound also. Okay, now we will further continue. Here they have written a substance could have a good oxidizing or reducing agent property, but it depends on its standard electrode potential, whether that electrode or that metal piece or that substance is good in what is like the ability of that substance of that electrode, whether it is good in oxidation, whether it will more lose the electron, or whether it is good in gaining the electron. So many substances can act as either oxidizing or reducing agents. So depending on the substance when they react with, and also with the condition they variate. Like this ability, this potential of a substance of the electrode, it variates with the reacting substance, and it do variate with the condition, with environmental conditions. Okay, here they have given us an example which is acting both as an oxidizing and reducing agent, and the example is of hydrogen peroxide. What is the formula? H2O2. H2O2. This is what we call hydrogen peroxide. So now this is ionic reaction in which iron plus 2 changed to iron plus 3 by the help of this hydrogen peroxide. Now we will assign oxidation number first. Now iron here, that is in a plus 2 state. Now hydrogen peroxide, here hydrogen, the charge on hydrogen, on one hydrogen it's 1, on 2 it will be plus 2. So on oxygen, on 1 minus 1, on 2 we have a minus 2, and minus 2 and plus 2 will be cancelled. That will be as a whole on this molecule, on this compound, the oxidation state, that is what? 0. Now what happened here, iron from plus 2 it changes to plus 3. And oxygen here it is in minus 2, 1 hydrogen plus 1 and 2 hydrogen, what? That is plus 2. So iron from plus 2 to plus 3. This gives you an idea. Okay, this iron is acting as what? This is acting as a reducing agent. Here it is acting as what? Reducing agent. So why? Because this iron has lost its one electron, oxidation number increases, and that lost electron is taken away by what? By this oxygen. Here oxygen changes from minus 1 to minus 2, from minus 1 to minus 2. Like 2 electrons are gained here in a water molecule. In hydrogen peroxide, 1 electron was gained. So this is acting as an oxidizing agent, because the agent which will help in the oxidation of the other but itself get what? Reduced, it get enriches. So this is what acting as a what? Oxidizing agent. This is you can call a thief of electron, but this iron is reducing agent, and this is very generous in providing the electron. Now this is the same reaction, but here the condition is a bit different. Now you can see we have written iron plus 3 here, but here the acidic media is changed. Here we were having acidic condition. Now the reacting substances, iron, and there was a hydrogen peroxide, but the environmental condition, they were different. Now this reaction was in the acidic media, and this reaction is in the basic media. So when we change the condition, now this iron is behaving in a different way. Here iron plus 3 changed to iron plus 2. 3 electron was not here with the iron atom. Now it gains 1 electron from another species, from this what? From this hydrogen peroxide, and it changed into iron plus 2. Here you can say, wait, iron oxygen is in a minus 1, for 2 minus 2, hydrogen plus 1, and for 2 hydrogen plus 2. Now here minus 2 and plus 1 and plus 2. So here oxygen is in a minus 2 state. So you can see, okay, from plus 3 to what? From plus 3 to, it changes to plus 2. Fine. So you can see from iron plus 3 to plus 2, this gives you an idea. Okay, there is a gain of electron, due to which oxidation number decreases. So when there is a gain of electron, this means this species, this iron here, is acting as what? This is acting as a reducing agent, the agent which help in the reduction of another compound. No, this is acting as an oxidizing agent. This iron here is acting as oxidizing agent, and this hydrogen peroxide is acting as a reducing agent. How? Now let me tell you. Iron here is acting as oxidizing agent. Oxidizing agent is an agent which help in the oxidation of the other compound. Like what? It loses the electron, it gains electron. This iron will gain electron. So yes, it has taken away the electron, due to which the oxidation number decreases from +3 to +2. Whereas in the hydrogen peroxide, what has happened, this is acting as a reducing agent, the agent which help in the reduction of the other compound. So yes, here the iron has gained the electron, but this reducing agent itself will become deficient of the electron. So first it was having 1 electron extra, it changing. We will compare now hydrogen peroxide with the transformation to oxygen. Hydrogen peroxide changes to O2. Water is something neutral. Okay, we'll not compare this hydrogen peroxide with water over here. We'll compare hydrogen peroxide with the oxygen, with molecular oxygen. So here oxygen was in a -1, and here oxygen, oxidation state of molecular oxygen, that is what? That is 0. So you can see when it is from -1 to 0, this gives you an idea there is what? There is a loss of electron. So a reducing agent is an agent which help in the reduction of the other compound, but itself get what? Oxidized. Itself get oxidized. So these reducing agents are very generous in providing the electron. So yes, it has given its 1 electron to the iron species. I hope so now it is easy for you to understand. Now this is your homework. This is your homework. You will do it on the Word form or on the page. You're going to take a screenshot and you're going to send me. Okay, inshallah we're going to start this in another lecture, 7.6. Goodbye.